Okay, so picking up where we left off, we were talking about months and inches of children, heights of children. We calculated the equation from months to heights. And so the next question we're going to ask is, can we use this exact same equation to predict a child who is, to estimate a child who's 50 inches tall? I'm sorry, can we go backwards? Can we use the exact same, in other words, can I use the equation to solve for y? And the answer is no. I need the LSRL that predicts x from y. Uh, we talked earlier about how the correlation coefficient doesn't matter, but the equation will. And so we're going to go back to our calculator, and we're going to make a new equation or new LSRL. So we're just going to go to Stat, Calc, go to the linear regression one, and this time I'm going to switch the order. So I want my X to be list 2, and I want the Y to be list 1. And then I'm going to store this equation under Y2 because, I might want to have Y1 still there. So if I go to vars, scroll over to yvars, and then just pick from the function I want Y2. And then I can compare the two equations right next to each other. So notice we get an entirely different equation when we predict the other direction. We do get the same r, but we don't get the same slope, which kind of makes sense if you think about if you're going from x to y, the slope should change on. But anyways, and if I go under y equals, I can see the two equations next to each other. Okay, and if I want to use this to predict at 50 inches, then I just want to use that y1. I'm sorry, I wanted vars. So I want y2 with 50, and that'll predict the age of someone who is 50 inches tall. And so I predict 86. Again, we might be looking at outside our data range, so we want to watch extrapolation here. Okay, next question is let's calculate x bar and y bar, and is that point going to be on the line itself? Well, interestingly enough, we can find this using, well, not necessarily one var stats, but two var stats. So if we go to calc edit and we do two var stats, that will do the x list and the y list simultaneously for us. So let me reset this so it says list 1 is x and list 2 is y. So at least I remember that when I do the interpretation. All right, so we hit calculate, and we get x bar of 62.7 and a y bar of 41.85. All right, so I'm going to suggest we write these numbers down for right now, because I would like to know if it's on the actual line itself. So what I'm going to do is I'm going to have the calculator predict y when given the 62.7. Now the problem is if I type in exactly 62.7, I'm estimating x bar, and I want to use it exactly as the calculator has it. We've actually seen how to do this. So if I go to list and go to mean, I'm just going to have the calculator redo the x bar, the mean of the x's. So let me do that. Mean of list 1. And then I'm going to store that. Actually, no, I don't have to store it, do I? I can just I can copy and paste that number down. So let me do that. So let me go get y1 again, because we still have that stored. So let me go to vars function, y1, and let me copy and paste this number down. And I should notice when I use the regression line to predict y, that if I predict the prediction of x bar, I end up getting exactly y bar. That's the exact same number that we used for y bar. So if I plot this, that point is going to be on the line itself. So the point x bar comma y bar is going to be on the Lsrl, and that's always, it is always on that line. Okay. Now, a couple of thoughts. Correlation coefficient and Lsrl are both non-resistant measures. So you got to think about, what does non-resistant mean again? Non-resistant means if we're dealing with an outlier or extreme data, it is easily influenced by that point. Okay. Some formulas that have come up, we might not have used them recently, but these are just a summary of all the different formulas that we've had access to. Let's see, this is the y-hat formula for finding the line of least squares regression. That way the calculator does this for us. This is if we're given specific data about observations and means. We could use this to calculate B1. B1 is symbolically represented by the slope. B naught, this B sub 0, is representative of the y-intercept, or when x is 0. And so symbolically, that's how we calculate that. And then another way to calculate the slope, a little bit easier than this one, is if I know the correlation coefficient and I know the standard deviation of x and y, then I can set it up in this equation and solve. Okay, so we're going to sort of work, I wouldn't say work backwards here, but we're gonna be given this summative data, and we're going to find the Lsrl based on that summative data. Okay, so we'll get the correlation coefficient, the mean of the x's, the standard deviation of the x's, the mean of the y's, and the standard deviation of y's. And the claim is, using all of those formulas, we should be able to find the equation, and then we can come back in and use that equation to predict. So let me get some space to work on here. So bear with. Okay, so here's our formulas, and here's the data that we're manipulating. My goal is to get this regression equation, and I notice, let's see, so B naught, this equation here, this guy, I need the y bar, which I have. I need B1, which I don't have, and I don't want to do this. I don't have enough numbers. Oh, I can find B1 from here. So I can't find B0, B naught yet, but I can find B1. So B1 is R times the relationship, the fraction of standard deviation of y over standard deviation of x. So let's so we got enough information, we can find that. So our R is 0.9981, sorry, 1. And I want the standard deviation of y on top and the standard deviation of y of x on the bottom. And then I'm going to just type that into a calculator. So 0.9981 times 8.4 divided by 11.6. Okay, so I get 0.72276. That's fine. And then I want B0, so B naught. It's a fancy science term for this. Okay, and that would be the x bar, or sorry, y bar, so 18 minus the B1, which is 0.72276, times the x bar, which is 40. So type that in a calculator. And I get negative 10.9104. Okay, so putting that all together, our y hat our LSRL equation is the negative 10.9104 plus 0.72276x would be what we are going to use to predict. Okay, so if I want to use this equation to predict 50 miles per hour, then I'm going to replace x with 50. And I can just type that into a calculator, and I should get, see if it's on my next slide here, I should get about 25.23. Okay.